Alright guys, so right now I'm going to give you an example of how to approach a word problem for systems of linear equations, because when you're given the equations it can be sometimes easy to do, but in problems with all these words sometimes it can be a little bit difficult to figure out what equations you actually need to be using. So the question that we're going to look at goes like this. The admission fee at a fair is $1.50, $1.50 for children and $4 for adults. One day, 2,200 people entered the fair and $5,050 have been earned from people entering. So what we want to do whenever you start a problem is to go sentence by sentence and figure out what is important information that they're giving you in the problem. So if we start off, the admission fee at a fair is $1.50 for children and $4 for adults. So we're just going to look at that sentence. So I can see, first of all, usually numbers are important. So I can see right away that $1.50 is probably going to be important for my problem. And I can see that $4 is important for my problem. Okay, so I have those two things. And then usually in systems of equations problems, they're going to break information down into categories. So in this case, I see that it's $1.50 for children, and $4 for adults. So $1.50 for children, $4 for adults. Because what we're looking for in these systems of equations problem are two variables in this case. So our two variables here look like they're probably going to be the types of people. So a variable could be, for a person, could be that they are a child or an adult. Okay, so I'm going to make sure that I keep on paying attention to that as I go forward. One day, 2,200 people entered the fair and $5,050 is earned. So if I look at this, 2,200 is important, so is people. And then $5,050 looks like it's probably going to be important too. Okay, so once I get here, I've highlighted or underlined information that is probably going to be important. And now I want to figure out what my variables are. So we already talked about how children and adults are probably going to be the variables. So I have children as variable and adult. So when we choose our variables, you have seen them usually in X and Y, but you can name them however you like. So I'm going to say that we're going to represent children with the variable C for children and adult with the variable A. Okay, so now that I've highlighted my variables, now I want to come up with my equations. So usually they'll give you some information at the start and then some information at the end, and you have to combine them. So I'm going to look here. One day, 2,200 people entered. So I know that 2,200 people entered, and between them, that is a combination of children and adults. Okay, so for my equation, my first equation, I know that the number of children, C, plus the number of adults, which is A, is going to equal 2,200 people. So I'm just going to write equals 2,200. That's going to be my first equation. So I have already taken care of one of my equations, and the second equation is going to come from this part. I know that $5,050 has been earned. Okay, so now I know that $5,050 have been earned. Now I need to figure out the combinations that give me, I need to put on this side. So I know that the entrance fee for a child is $1.50. So for every child that comes in, they pay $1.50. So I'm going to write that down. So 1.5 C. So I'm getting $1.5 for every child. And then I know that I get $4 for adults. So I'm going to write 1.5 C plus 4A equals 5,050. So here, I've used all the information from my question to set up my two equations. Once you get to here, it's elimination, substitution, graphing, however you like to do it. But the hardest part usually in word problems is being actually able to figure out what information you need from the problem. So this has been the video on how to extract information from word problems. Please let me know if you have any other questions.